Today we are talking about writing and solving inequalities. Inequalities work a lot like equations, except for that instead of an equal sign, we see a less than sign, less than or equal to sign, greater than sign, greater than or equal to sign, or not equal to sign. So today, let's start with our less than sign. So we're familiar with our less than sign. If we see an expression where b is less than 4, then if we wanted to graph that expression, we would put that inequality, we would put an open circle on 4 to show that 4 is not a solution, that b cannot be 4. And then we would draw an arrow to the left showing that all of the solutions for b are going to be less than 4 on the number line. Then if I have less than or equal to sign, the meaning of less than or equal to sign would be like e is less than or equal to 8. So if I were to graph that on a number line, I would put a closed circle on 8 because this time 8 is a solution for e. 8 is less than or equal to 8. So a closed circle on 8 and then an arrow to the left to show that all of the values that are true for e are going to be less than 8. For greater than, if I have an example, a is greater than -3, I'm going to graph an open circle on -3 and draw an arrow to the right to show that all of the solutions for a are greater than -3, to the right of -3 on the number line. Then I have greater than or equal to. Like x is greater than or equal to -12. Then the solutions for x are going to be a solid circle on -12, and everything to the right of that would be true for x. Then I have not equal to. So if y is not equal to 3, I'm going to put an open circle on 3 because 3 cannot be a solution, but anything to the right and anything of the left could be a solution for y. So if I want to look at an example of solving inequalities, numbers 1 and 2 are examples we solved in class today. And then let's look at a third example. So if I have x, like down here, -6 is greater than or equal to -4. The first thing I want to do is get x by itself, just like I do with an equation. There is an addition property of inequality and a subtraction property of inequality, just like an addition property of equality and a subtraction property of equality that we studied with equations. So what that means is that I can add the same number to both sides of my inequality sign and the inequality remains true. So I can add a +6 to the left. If I do it to the left, I have to add it to the right, so a +6 to this side. I'm trying to get x by itself. And -6 plus 6 is 0, so that part of my inequality goes away. I'm left with x by itself. My greater than or equal to sign stays the same, and -4 plus 6 is a +2. So then my solution for this inequality is to be true, anything for x is greater than or equal to +2. So I'm going to box that answer. And then if I wanted to graph that solution, I'm going to draw a simple number line. I need to make sure 2 is included on my number line. And since it's a greater than or equal to sign, 2 can be a solution. For example, if I plug in 2 for x, 2 minus 6 is -4, and -4 is greater than or equal to -4. That would be true. So since 2 can be a solution, and I know that from this particular symbol right here, this is my greater than or equal to sign, I'm going to put a closed circle on 2. And all of the values for x, my inequality tells me x is greater than or equal to 2. So anything that's greater than 2 or equal to 2 is a solution. So I'm going to draw a solid arrow from 2 forward to the right to show that all of my solutions for x are greater than or equal to 2.